Video coverage of the 27th JCT Traffic Signal Symposium is brought to you by Highways News, thanks to our sponsors AGD Intelligent Traffic Systems, Clearview Intelligence, PTV Group, Message Maker Displays, Smart Video and Sensing, SRL and TRL.
Lovely stuff. Right, yep, so I'm Rob Whiteside, yeah. I've been in the signals industry for quite some time. You can thank Mr. Andy Knowles for that, who gave me my first opportunities. Just to introduce the names on there, presenting with me today is Keith McCabe, CEO of Simplifai. Also on our team, but not here today, we've got Professor Lee McCluskey and Maro Valletti, shall I say, sorry. They are both lecturers in AI at the university and both clever chaps. And then alongside myself, we've got, some may know him, David Clegg, who previously worked as a config engineer at DNIC and as Sheffield, and he's been around as well. So we've got quite a team there. So when I joined Kirklees, I was fortunate enough to be asked to collaborate on this AI project. So myself and Dave, we were tasked with kind of, we've jumped a slide there, but that's fine. We were kind of tasked to set up what was required for the AI team with regards to data. Just to give you a bit of an overview, which is what this slide is, that is kind of the corridor that we looked at there. That's Wakefield Road, around about 2 miles long. I think it's got about, there's 9 junctions on there, 3 PEDs. One of them's a multi-node Scoot junction as well. It's speed control with cameras 30 mile an hour all the way down. There's a timed bus lane for peak times. In the morning, that runs inbound but not outbound, and when the bus lane's not in use, it turns to a car park, basically. So, there's quite a lot to that. Also, around about the town area, we've got the university there. It comes into the ring road, and nearby there is the stadium as well, the football stadium. Let's see if I can jump forward a little bit there. There we go, a few of the Scoot links that are on there. And a bit of a view there. So mainly we were concentrating, although we did look at the whole corridor, there are 6 junctions which head into town towards the ring road, which we kind of started to look at and collect data from. So our system is basically, like many people, it's a Scoot system, which is now hosted. It's a Swarco Scoot, and we also have InCity on there as well. Probably what didn't help is COVID, which didn't help anyone, which happened just at the start of the project. And also we migrated the system to a cloud-based system, which kind of changed how data collection was done. Also along the corridor, hardware-wise, they're mainly PTC1 controllers with chameleons connected by a wireless mesh system as well. So there was various data sources. Yep, we've gone back, that's fine. What we needed, first of all, there's the static data, what needed to be collected, such as controller specs, drawings, Scoot plans. You've got region data, network and link data, as well as other things like fixtures listings from the stadium. Obviously, when you start doing this and you've got old jobs out there, over the years, the controllers were changed, but maybe things on site, so detection wasn't exactly the newest out there. You start to find errors, and you try to correct those where you're picking them up as well. The other thing we needed to collect was the dynamic data from the system. No, it's still not there. Sorry. Bear with me. So what we needed to do, we wanted to start to collect the messages from Astrid, the M messages, and also the Rflow data. It was quite a challenge, really, because anybody who's ever tried doing this within Astrid, use the AS2 to MES Astrid to message command strings. and it's a bit like pulling teeth. It's not really designed to pull out days and days of data. So we found that we had to generate the strings using Excel sheets, and then obviously went over to cloud-based. You then had to open a session up where you could execute those, and then it was a case of writing batch commands which could then extract that data and convert it into text files, which made it then it made it into a readable format, which could then be entered back into the AI system. It was also quite a time-consuming process because a lot of the data is second-by-second data, high resolution, and again, it's only held on the system for 2 days really before it goes to a low resolution. So it was at one point it was every other day collecting the previous day's data, and it was you're probably talking for 6 sites to FTP it all down with maybe 40 minutes. So a good time to go grab a coffee. I think that highlighted one of the issues, actually, which was Astrid, in its current form, Astrid into a modern database, so you can't query it easily. However, we have to thank Swarco for their assistance in creating login details and on the cloud-based system to pull this. And it may be an avenue there where APIs could be maybe funded through the TTF to actually get a common protocol for interfacing maybe third-party optimizers into these control systems. So alongside this, obviously, we've got the Scoot data, but then we've also got this large amount of other data, which is out on the slide. So we've got weather data, Bluetooth monitor data, pollution data. We've also other things like Strava, One Network, and we've got the asset management. So there's quite a lot of data that it's all come together, but at the moment it's all processed by us, and it's a bit hard to start cross-referencing what happened on this date, what was the weather like on that date, did that have an effect on it? So what we were looking for is maybe some solution which can actually bring all this data forward. I mean, that's the type of just a general overview of the type of graphical interfaces from different systems that we've actually got access to. I mean, the way we are staffing-wise in Kirklees, we don't actually have as own UTC centre where somebody's constantly monitoring traffic. We're kind of more reactive. So what we're looking for is maybe when a system that could, if something was happening on that network, highlight it to us, or an overview of all systems. It's fine having these separate systems to drill down, but it does get rather too much, and we haven't got that many monitors in office, I don't think. So ultimately, this is where we're kind of wanting this system that can interface, pull this data out in real time and display it, and then we can feed that back maybe into the system to produce optimized signal timings, which I think now that's a good time to hand over to you, Keith.
Okay. Thank you. So as Rob said, I'm Keith McCabe, CEO of Simplifai Systems, and have a number of other hats, but I don't want to take up too much time on that. Actually, what I want to take up the time on is say that creating a cloud with all the data in is easier said than done. And I think Rob has highlighted some of the issues. And I think if I was to make a recommendation, trying to get all traffic data into GeoJSON APIs would be a huge step forward, and probably get a few more hairs back for software engineers who integrate data, because they found integrating very large text files a bit of a challenge, but we got it done. But the reason we did it is very much along the lines of the AIMSOM presentation as well, is by analysing the past, you can get an insight into the future. Because what we've set a system up to do is really understand what to do next when something goes wrong or there's something out of the ordinary. Because that's the key. You can create these things, but actually changing the outcome is where you make the difference. However, we did find a few other things on the way. So one of the things we wanted to understand is, I think at the moment we've got about 30 gigabytes of data in there, and we're now incorporating bus open data, which is ramping it up quite quickly because the bus open data is quite large. But what we tried to imagine is, well, there's loads of people who are stakeholders in transport in a local authority, and they don't all have the same interests. So what would it look like if, say, you gave a dashboard to people who run public transport and had a click-through that said, right, there's an incident there, let's just reconfigure the traffic signals to deal with that incident. And that's the sort of system we're looking for, to actually make it so the traffic engineers are involved in setting it all up, but actually the ones who want better outcomes for public transport or for air quality or responsible for the carbon agenda can be involved as a stakeholder to implement the strategies, because we've got an agreed method to work them out. However, again, easier said than done. I think when we first formulated this, we thought that actually there's quite a few things you want to do with your existing asset. Because if you compare the cost of AIM-Some Live or the cost of this or something to the cost of the whole traffic signal asset in any local authority, what's already there is the important thing that's worth a lot. And we need to get so much more out of it. And we've now got different demands on what we want to achieve. I thought there were great presentations earlier on what happens if you focus on the carbon agenda or the air quality agenda. We should also be thinking, what happens if you focus on the carbon agenda or the air quality agenda in operations, in how you optimise the signals and how you run them and set up the algorithms to do that. And that's where our starting point. However, for the project, we mainly focused on maintenance and also trying to do something about things that we knew were going to happen. And the example I use is a football match. However, to do that, the first bit that was quite interesting from a maintenance point of view is we use a form of artificial intelligence called planning and scheduling. I could stand here for hours to talk to you about how it works. I could even share our 57-page patent that describes how we make traffic signals into something that's machine readable. But the essence of it is it gets knowledge of the network and understands what levers it can pull and understands the current context, and it has a goal to achieve. Now, it's a form of AI that's widely used elsewhere, but this is the first time it's been used in traffic control. One of the examples where it's used elsewhere is in space flight. It's used to control spacecraft where you can't micromanage them because of communication delay. So you give it a goal, and the Mars rover, which used it, goes off and collects samples and works it out as it goes along. Well, we use the same principle. However, the one challenge you have when you do that with traffic control is we're really good at detecting upstream what flows are. What we don't have is regular monitoring of where they go when they get to the stop line. There's a few good systems coming out now. I think we're hearing from Vivacity next, who can detect what happens after it goes past the stop line, where things go. But we worked out a machine learning model to turn upstream flows into downstream flows and where they go. But in doing that, and this is an intriguing one, is we validate against various data sets. And what we found is not all of the detectors were actually showing the flows as they are. Because when you're doing a machine learning exercise and you're trying to validate, all the numbers should add up. And a few of them weren't. And what was good from a maintenance point of view is we worked out why they weren't and then went in and intervened and sorted them out. Some we didn't, because actually they weren't making a jot of difference, so you don't have to maintain everything. But others were. And I know in quite a lot of places there's scoot loops over a number of lanes. We noticed that was causing a problem with the counting. It's also causing a problem with operations, but we make the case for changing it. And I think that's, in some respects, the purpose of the maintenance fund is to use data and analytics to understand the data sets and use that to make decisions about what you should maintain, what you shouldn't maintain, and improve the operations. So we did all that, and if somebody wants to talk to me about how you do it, happy to do that. But here's an example, and I think this, To me, I couldn't, if people have ever seen me present before, I can't do a presentation without a graph. So I've got a graph. And what this shows is a football match. So 3 of those lines are when Huddersfield Town were playing, 3 of them when they weren't. Graph on the right-hand side, for my right, your left, shows flows. And the interesting thing is, actually, after a game, the flows are less than they are normally on a Saturday afternoon when there isn't a football match in the middle of the day. However, the graph on the other side shows the congestion, and there's another one I could show for delay. So what we were finding is a football match has a disproportional impact on the network because the network at other times can cope with that volume of traffic. So what we need is a different form of intervention. And I think I really like the last presentation because it highlights the issue that you can detect incidents and you can know there's big disruption. The challenge is then to do something, because even on that simple network of 6 junctions, Margaret might contradict me here being a nuclear physicist, but on that 6 junctions for half an hour, the amount of permutations you could have of traffic lights is close to or more than the number of stars in the universe. So you've got multiple permutations. AI planners are very good when set a goal to go through those permutations really quickly and say, actually, this is the one that solves your goal. So when we started, as folk here from Manchester would know, we started off and we could do the next 5 minutes and it took us an hour and a half. Not great as an operational tool. Now to come up with a plan for a football match takes us less than 10 seconds for the next half hour. And that's in the circumstances that it faces at that moment in time. And the reason why there's differences in the amount of congestion from those 3 days is one of them, Huddersfield Town, were getting thumped 3-0 at home, so people left slightly earlier. So actually the congestion was at a different time and wasn't quite as bad. The other 2, it was close. One was drawing and one there was only 1 goal in it. So the traffic patterns were different. However, if you link the AI planner through to the football feed to know what the score is, and at Huddersfield Town it's not as pronounced as where I'm from in Manchester, where they're very susceptible to the score, you can then actually have things triggered by other things rather than traffic control and start to come up with solutions that can actually address what I think is now more important than the recurrent congestion is the non-recurrent. Because when we're looking now at bus data, the issue we're trying to solve is make buses more reliable and run to timetable, because that's how you get the patronage up. And we think by systems like this, we can do that. And where it goes from now is, I think, we've got stuff that's ready to deploy. We have data in the cloud, and we think, you know, given it's not huge amounts of data, this can be continued and rolled out. I think there's some questions for the industry, though, because the existing systems are very valuable and need to continue to be used. And I think actually make them accessible in a smart city way would be really beneficial to the industry. And we discussed with all the suppliers about doing that, but maybe there's a role as an industry as a whole to take a role in that, because I think I was stunned when Rob, at one of our previous presentations, come up with that screen with all the screens that he looks at. And I thought, how can you manage traffic from home like that? So we need a different way of doing it. But maybe I'll leave the last word to Rob and he can say what we might do next.
Super, thank you, yeah. So, I've done it again. I've jumped further forward. Yeah, so what we're looking at now, all right, turn this off on first. There we go, can you hear me? Yeah. Yeah, what we're looking at now is maybe this integrating the other technology and bringing it all together in maybe a common dashboard to be able to identify faults. There's also, we have skipped forward a slide, I think, here, Keith. There we go. Yeah, there's also other things such as V2X and V2All for vehicles and the new AI cameras, bringing that data in where we can actually count and classify actually track HGVs and buses through a network. And I think as the network expands, the data will become more rich as well. Looking forward as well, we want the AI to be able to generate scenarios and plans and actually take more of the user interaction away from it and be able to make the decisions on its own. And also, it then allows better compliance with policies and local traffic plans as well. Do we have any questions?
Thanks, guys. We've got time for 2 questions if we're quick. Hands up. If not, I've got my first one. Okay, I'll take one of them. Okay. Any considerations for cyclists? I've got to say that, haven't I? You had it as an input.
Yeah, I think there always is. I mean, again, we are looking at these AI detectors. You know, there's a lot out there. There's the stuff that Clearview's doing, the stuff that Fleur's doing, AGD and all this. And it will be good to bring that in. And that's what we want to do. You know, that's the idea of being able to bring all these rich sources of data into one place and use it in the AI system.
And also, we can set whatever goal a local authority wants. So if the goal is at any particular time to prioritise cycling or walking, and we'd put that as the goal. And
Correct
let the
answer.
planner sort it out.
Correct answer. Good. Any other questions? Oh.
I'm wondering if there's any analysis you've done of running different events at the same venue, as in concerts at the same football stadium, and if there's any learning to come from that and the distinction, time of day it happens, that sort of thing.
Loads.
I think there's opportunity, isn't there? Because there's obviously the football team and the Giants run from the same stadium, and I think recently we've just had Green Day on. Yeah, so we've all got all that data to analyse and see, well, how did that affect it, you know? We're also in talks with, like, the stadium events staff as well, because a lot of the car parks, they hold back the traffic, you know, until maybe the players have gone or the away team's gone, and then that gets released as well. So, you know, it's not only knowing what time things finish, and it's also knowing when this happens and liaising with the staff who actually release it, you know.
And also the other thing is people get to stadium and go from stadium in different ways. Quite often it's sensible to allow the people to walk away before you let the traffic go, and let the traffic go in a managed fashion. So you don't necessarily want them all to go at once. So you've got to manage it. And I think we found on that corridor there, the problem was actually a junction quite a long way away, because of the tidal flow nature of the traffic after an event, gridlock that junction, which then queued back into the town. So you've got to kind of manage it so it doesn't overload one of your pinch points or gridlocks as well.
Great. Well, look, really, thanks very much, guys. I think the last 2 presentations, and probably the next one and the next one as well, have really shown that actually there is technology for technology's sake, and that AI is coming to help us in the roles from a traffic engineering, traffic management perspective. So put your hands together. Thank you very much.
Thank you.